to Meet the PI, presented by Animal Behaviour Live. In this podcast, we sit down with leading researchers to explore their research journey, the challenge they faced, and advice for the next generation.
Hi everyone for this new episode of Meet the PI podcast. For those who did not listen this podcast before, I will try to explain a little bit the aim behind. So the idea here is not really to talk about science itself, but more beyond science, like the life of the researcher, trying to understand like what motivates them to continue in this path, if they have some difficulties along the way. And also like maybe try to understand their strategy when it comes to funding scheme, this type of things. I'm Alexis Buatois. I'm a researcher at IAVAG in Switzerland. I'm working on ecotoxicology and learning and memory in zebrafish. And today I will be joined by one of my colleagues from ABL, David McCluskey, who is retired in UK and also studying environmental science. In today's episode, we will discuss with Wen-Sung Chung. So thanks, Wen-Sung, for being here today and give us some time for this podcast. So Wen-Sung, you're currently a postdoctorate at the Marine Sensory Ecology Group at the University of Queensland in Australia, within the School of the Environment since 2014, if I'm not wrong now. And so you and your team are working on understanding neural networks underlying intelligence in cephalopods. And to do that, your team is combining high-resolution magnetic resonance imaging with behavioral observation in cephalopods. So for our audience craving to know more about your line of research, we definitely advise to register to our free annual online conference, the 13th and 14th of November, during which you will actually give a plenary presentation called Inside Out, Sexual Dimorphism and Neuroplasticity Shape the Brain in Behavior in Cephalopod. But so today, as I said, we are more here to discuss about your journey through academia. And to start, I think we can go with the most evident question. What turned you into studying cephalopod and more particularly into understanding the brain mechanisms underlying their intelligence?
Yeah, thank you for having me to be here and share my experience with you guys.
Thanks a lot.
Okay. I have a very long journey on cephalopods since my undergrad. So I was very lucky to meet my former supervisor, Chongchen Lu, in Taiwan. I originally from Taiwan. And because I volunteer in the museum to prepare the sample for exhibition, so I knew him in very early age. And then that's what I started working on cephalopods. So I have very long experience to do taxonomy. So I know many species. So I visit many different museums to see many holotype, and then also a lot of new species in Taiwan. So give you guys an overview, cephalopod around the world, roughly about 800 species. But in the Indo-Pacific region, the diversity is much higher. So for instance, in Taiwan, such tiny island, we have roughly 150 species.
Okay.
Yeah. And Australia, roughly 250 species. So that's almost half of the global species around these two regions.
Okay, yeah.
In the beginning, I really, yes, I have a lot of training on taxonomy, so I know the morphology, and I can see so many different diversity across different habitats. That's really let me get into this field because some of them looking so weird, especially those deep sea species. It's just so strange. It's not like a normal cephalopod. It's so jelly, and some of them is translucent. You can see through the body. You can see the neuron. You can see the brain without microscope, without MRI machine. Yeah. And I came to Australia for my PhD in the deep ocean Australia. So I got a lot of opportunity in the deep sea expedition. So during my PhD, I spent roughly 4 or 5 months at sea, just doing a lot of sampling. Yeah. So because I have a lot of background about taxonomy, so I really want to keep those deep sea rare species in a good shape. So that's my the first idea. If I can find some way to image the animal, especially those super rare ones, and keep those digital image, then many people can see that even they unable to have the deep sea expedition to see the real animal. So that's the journey get into the brand because I get very lucky at UQ. We had a very powerful MI machine, so I can see super high detail inside the brand. Yeah.
Okay, very interesting. Before your PhD, you were not in Australia, right?
No. Yeah, I did my undergrad and my master degree in Taiwan.
In Taiwan, yeah.
So yeah. So working on octopus embryonic development and the squid like a life history project. Yeah.
And so how hard was the transition for you, like to pass from Taiwan to Australia? Because like I imagine that it comes with some challenges, like leaving your family behind and like maybe some of your friends. So like how was it for you? Like how did you like bypass this challenging, like try to make it a little bit less hard?
Yeah, very lucky I got scholarship. So that's the first reason I came to Australia. And also that's the Deep Ocean Australia project. I really want to do the deep sea research. So that's the very rare opportunity I can join that team and developing our the midwater net system and the deep sea camera system. I also super lucky joined giant squid expedition back to 2012 in Japan. And we filmed the first ever live giant squid in natural habitat. So that's during my PhD. Yeah.
Yeah. Okay.
Do you find that you're having to bring lots of different skills to it? Because it sounds like you're out there, you're developing camera systems, you're using MRI systems, and so on. Do you become expert in all these different areas?
Yes, very lucky because all my supervisor trust me so much. So I really can get touch all those fancy machine, and also we have a workshop so we can modify based on what project we want to do. So yeah, it's really provide me a lot of opportunity, not just learning how to do it, also have the opportunity to modify it. So we need to get into that. So for instance, the MRI is originally developed for mouse brain for the 16.4 Tesla machine because that scanner is very powerful, especially for the small animal. But before me, there's no one ever tried marine animal in using that machine. And then one day I have a chat with my colleague, say, "Oh, I have a very complicated animal. Could I put it into the scanner and see what is going on?" Yeah.
So you have to become an engineer and
Oh, not really. Yeah. I'm still biology background.
Yeah.
But I try to understand more background so I can know. I know. Oh, okay. We can try this way. We can try that way, and optimize the protocol and the image quality. Yeah.
And are the different departments in the university willing? Are they open to working together with other departments and trying to, allowing people to put marine animals into MI scanners and so on?
Yes, I think that's the UQ is a very open environment. So we have a lot of chat during the morning tea time. So we have a lot of chatting. Or we have some challenge here, and we know we have this facility. Can we try it? Yeah. Then we have have a plan and how to tackle this task. So I remember in the very beginning, I used squid as the first sample because it's much easier to get it. And then we know more about a squid nervous system than octopus, to be honest. Yeah. And then we try different contrast agent and optimize the image quality, and then start from the whole individual, and then get into the isolated brand and push the resolution to the current format. We can do it.
But and actually, like I imagine that ethically speaking, like you have a quite long journey between the moment that you get an idea of experiment and the moment that you obtain the authorization license to run it, right? Or how it works. Maybe you could explain, how in Australia it works to get a ethic permit, for instance, for this type of experiment.
For the scanning,
Yeah.
uh, I'm not working on the live animal, so it's relatively
Okay,
easy.
okay.
Yeah. So the functional MRI, that's really challenge. So that's my long goal. So
Yeah.
if one day we can persuade the manager to allow me to put the aquarium with the seawater and with the live animal anesthetize and put into a scanner, then we probably will give it a try about functional MRI. However, there's a major challenge because functional MRI is detecting oxygen. Using vertebrate or the human using hemoglobin is much easier to detect the signal. However, cephalopod using hemocyanin is copper-based, is not the iron-based. So the signal is super weak. So that would have a lot of challenge ahead. So we don't have the idea how to overcome this challenge yet. But well, yeah. If someday I got enough funding and I have all those techniques allow me to try that, I will definitely try it.
Actually, so like it's interesting because like several times you said challenge, and so like we can clearly say that working with octopus is coming with his load of challenges. So maybe like you would have some advice or caution for people who are interested to work in marine biology.
Working on marine biology, especially, I also spend a lot of time in the natural habitat. So you need good skill doing the field work, like scuba diving, or you not suffer too much for the seasickness. I have a lot of diving experience, so I know a lot of. You need to stay in the field to see the animal, and then you have some idea, and then you search for some tool to help you to overcome these challenges. For instance, I spent a lot of time in coral reef, like Great Barrier Reef, doing a lot of scuba diving, but you need to know how to find them. So working on octopus, one major challenge is very difficult to find them, especially when they are so well camouflaged. Yeah, I remember when I first time to working on algae octopus, I spent 5, maybe 7 days on the reef flat. The first 3 days, I got nothing. I can see ink, but I just unable to find octopus because they are so well camouflaged. So you need to spend time to get those experience. Then you know, oh, when I see the ink, then octopus must be somewhere nearby, and then the experience to help me to find them.
So which means that it's also coming. Like, I mean, you cannot really think about having a career in marine biology if you are just passionate about the species itself. You also sort of need to be passionate about sea and ocean by
See
themselves
the ocean and then learn from animal.
Yeah, because you really need to know that you will spend a lot of time in water searching, and that you not only need to understand the behavior and ecology of the animal, but also all its surrounding to be able to kind of find it.
Yes. Yeah.
Do marine animals, because their environment is so different to ours, does it present special challenges for interpreting their behavior?
Yes, because underwater, especially for the behavior observation, you have very limited time to see how they interact with other animal or their sibling, for instance. Yeah, so if you're just using scuba diving, in 10 meters, you probably can get 1 hour observation time. So, but not always you can have that 1 hour. You're just watching one behavior. Most of the time you spend a lot of time to search for one pair octopus doing mating, for instance. but you probably just have another 15 minutes to see how they interact. So this really have the limitation to let us have less opportunity to see the real reaction. So we are the group very lucky. We're using rebreather, so the closed circuit rebreather diving system, so we can stay underwater for 4 hours.
Okay.
So let's really optimize our underwater time to see the real interaction between octopuses, or for instance, the squid have the schooling behavior, or the cuttlefish camouflage, etc.
I think because like a lot of people, I guess that my main source of information about octopus recently was my octopus teacher on Netflix, and what I learned from it was that it took him a lot of time to kind of familiarize the octopus with himself. So I was wondering, like for you guys, like do you also have to kind of take a lot of time to stay around the octopus for them to get used to your presence? And then like that you are not somehow like not creating a bias, but like maybe preventing some behavior by just being here?
Very different approach. So I think, well, for my case, I spend really a lot of time in the field. So not just doing the scuba diving, also doing just like a beach walking or the reef flat walking to search where they are and what kind of habitats they stay. And then we can set up the camera or the trap or just snorkeling to see what they are doing.
Okay.
That's the first approach. And then we also can keep them in the aquarium system, so we can set up proper camera system to monitoring how they interact or how their activity during daytime or nighttime.
Okay.
Yeah. So that's so we have a lab work as well as the field work.
Are they social animals? I mean, if you find one, do you find lots, or are you just seeking one animal out in a massive ocean? Okay.
Yeah, depends on species. Most of them, especially octopus, are solitary, so very often just found one. But because I know the area and I know the habitat, so I'm much better to catch a few in one afternoon, for instance. So like my recent study, the blue line octopus, the mating copulation behavior, that actually about 5 years experience in the same area. So we know when is the spawning time, and when it's much easier to find a mature male and a female. So that's actually accumulate from a lot experience, and then we can set up the camera system in the well-controlled environment, and then do the proper filming.
But so actually, because during our conference, we will hold a workshop on climate change and maybe what it trigger in terms of change of research strategy. And we were we wanted maybe your feedback on this. Like, did you have to change at all your way to approach octopus, or due to climate change? Like, do you have the feeling that maybe behavior change, or I mean, obviously due to water temperature, these type of things, that actually forced you to also adapt your research and your exploration strategies?
Yes and no. Recently, Brisbane, over the past 10 years, we have 2 major flooding. And then my collection site is very close to Brisbane Bay, the Moreton Bay, so very close to the downtown. So the flooding actually affects the whole area. So after flooding, I cannot find any cephalopod because they are unable to tolerate the low salinity. So I need to search for different location and maybe increase my field work time to try to find where they are and what kind of habitat I still can catch them. Yeah. Another challenge is in Australia, we have a very strict collection permit. So every year, I only can collect certain number of one species, for instance. If I need to collect that in Great Barrier Reef, that even tighter. So most likely will be one species in one site for 5 individuals per year. So if I need a lot of sample, I actually need to travel so many places to find them. Yeah.
But actually, it's interesting because here, so like you definitely describe the fact that it's very time consuming to get your sample, and so like we could wonder like how do you actually balance like between personal life, research, I guess teaching, and other things that are coming with research. Like how do you do that?
Yeah, at this stage, I'm not involved. I'm not involved in a lot of teaching.
Okay.
So I'm still research focused, research fellow. So I can spend a lot of time in the field.
Okay.
And also, I think in marine station, our marine station is actually quite family friendly. So you actually can bring your family member along when you're doing field work. So my kids actually learn a lot of octopus behavior or squid. They know a lot because
Do they share
joined
it?
my yeah.
Do they share your enthusiasm for octopuses? Are they going to follow your
Your lead, yeah,
I'm
on
not quite
this.
sure that part, but they definitely like the octopus. Yes. Yeah.
Okay, so potentially you will already get a new student soon. For
That is important, I think, when
Yeah.
you have a family that shares your passion and enthusiasm and supports, because it is a real commitment,
Mm.
particularly with the sort of long times away and field work and
Yeah.
so on.
Yeah. It's not just cephalopods. They also enjoy to see fish or other marine animals. So that's also very lucky in Australia. In overall, the environment still very healthy compared to some other region. So they actually can see the real situation in the ocean. Although recently we have some coral bleaching event, it's really bad, really sad to see so many coral die, but they still can see relatively healthy environment in such a young age. Yeah.
Yeah.
Mm.
And so, like, do you have the feeling that somehow, sharing all of this with your kid is also something that help you getting some skills into outreaching and just like presenting your research to global public?
Yes, I very often join those outreaching event like an open day. So yeah, cephalopod always very attractive for people, especially we have so many different species, and that many of them are so beautiful, and the camouflage is just fascinating. So
Yeah.
just showing them video or some behavior that's actually very easy to engage with the young students, and then that help them to know our ocean better because cephalopod octopus, they are iconic animal.
Yeah.
Yeah, so I think that's the very my advantage can outreach to very different audience, and then from the young student, young kids to the LD and those really like ocean. Yeah.
But I guess the fact that it's also an iconic animal, maybe sometimes it's a bit challenging for you to not like that people understand why you are conducting research on them. Because like I guess that sometimes people have this view that research is really like we put needle in the animal or this type of things. And so like maybe do you have this challenge when you are presenting your research to people?
Not really. I don't
Okay.
really have let those kind of challenge. Yeah, I do have, or people do ask some really challenge question, like they have a very short lifespan. So what is going on, and how can we help this soft body animal in the ocean? Yes, we have a lot unknown, but that's also a good opportunity to make them to think. Oh, we really know very little about marine life.
Mm-hmm.
Yes, yeah. So I always use these different cases to explain. Like a fish can live over 20 years, but octopus, many of them only can live 1 year, but they can learn very fast.
Yeah.
and how they can live together in the ocean, and then some of them even cooperate hunting together.
Okay.
So the learning capability and how they learn so fast, but somehow they are unable to transfer all their knowledge to the next generation. That's really fascinating, and then that's how evolution happened. Yeah, so that's really get me into the brain evolution. Why this guy have such a complex brain, but they are unable to live longer and are unable to pass all those knowledge. And what's going on compared to vertebrates?
And so like a long-term goal will be also to be able to compare, I guess, as many species as possible in order to actually understand how these capabilities are really conserved among every species, or?
Yes, that's the one project, one project line. So at this moment, I have scanned over 35 species.
Okay, that's
Yeah,
impressive.
although I haven't published yet because some species is really difficult to get. So it's very hard to get enough number to do the proper analysis. But I do want to do the broad range comparison because, yeah, different habitats definitely these guys have very different strategy to live in that kind of environment. Yeah,
Okay.
and I also scanned a few species, many of them. So one challenge for cephalopod neuroscience is very difficult to get enough number specimen. Yeah. So far, our for instance, the brain anatomy or brain atlas, many study, including mine, the sample size are very small. So 5 probably already a lot for most of the case. So in my mind, I want to make one brain template like a human brain. So we can use that as the template to compare many different questions. For instance, the sexual dimorphism between male, female brains, what is different, and how much different between two sexes. We have no idea about this. So I'm currently working on that, and hopefully this first ever octopus brain templates will publish within a year. Hopefully, yeah.
Yeah. Okay. But we cross fingers for it. Because like you say, so it's a lot of sampling. It's a lot of time, and so I was wondering if you have a big team of students to help you in this task, and if yes, because I imagine that you have a very particular case here, because actually, like you say, sampling is not that easy because you need to know where to search. You have a lot of things to understand. So what is your strategy actually when you have a student coming in your lab to actually teach them in an optimal way? Because we know that sometimes internship can be really short. So how you deal with that?
Yeah, I have a few students working with me on octopus recently, also ongoing. The easy way is bring them to the field.
Yeah.
Yeah, so I think the field work is really teach them a lot. So they need to learn how to find octopus. So during that process, they need to learn the habitat and what kind structure octopus will live in. So the burrow shape look like this will live in, or will have some species living here, and the different species will prefer different habitats. So that's the first step. And then we spend a lot of time in wet lab, so setting up the tank to observe their behavior. And then the really challenging part is how to train octopus to do the task. Yeah, we try. So far, we have 2 species. We really work more focused on 2 specific species. And somehow, well, to be honest, octopus, they do have very strong personality. Some of them really can learn very fast, but some of them just very stubborn, just watching you. I'm not going to do anything. Or somehow living in the aquarium become too bored. And yeah, I'm just not doing anything. Yeah, so you need to find a naive one and train them again and then see how long they can remember this task, for instance. Yeah, that take really long time to get the project done. Yeah.
And so is it something that you start with when a new student is coming, like just explaining, okay, it will not be easy, so like to be sure that
Yes.
they will not get
Yeah.
frustrated too much, because like it's actually a discussion that we had yesterday in our previous podcast about the fact that sometimes students are getting frustrated because like there's no positive result. So how do you approach this with your student to be certain that they are not getting too frustrated by octopus watching them and saying, I will not do anything today?
Yes, so we always have at least two small projects together.
Yeah.
So always have a plan B. So if you're unable to make the behavior project done, then you still have the brain anatomy or some like a brain mapping project you can do it. Yeah.
Okay. Yeah.
Yes.
You say it's hard to train octopuses to do things. Is that, and you sort of imply it's because they don't want to. Do you suspect that? I mean, it's difficult not to anthropomorphize, but it's just I get the feeling these are clever animals, and they you read anecdotally about the things that they do, and how difficult it is to keep them in aquariums because they escape, and
Yes.
these are clever animals.
Yeah.
Are they just, I don't know, are they just like cats? They just don't want to be trained.
Yeah, really depends. And okay. We try to use the positive encouragement for the learning enhancement. So we don't use the punishment to do the negative control as the old style, because the ethics and the animal welfare aspect. So using that way, sometimes really spend a lot of time to make octopus get associated with the reward and then your task. And then sometimes this training process will take too long. And then because they live in the relative small space compared to the natural habitat, so that probably will affect their behavior as well. They'll become bored and also change their circadian cycle, for instance. We don't really know the detail yet, but using this way, we sometimes we really encounter big challenge as all other labs working on octopus. Yeah. And then Australia, we also have the nighttime, nocturnal octopus and the diurnal octopus. So usually they are nocturnal,
right?
But we have the pure diurnal species, and unable to train them to do something because close to sunset, their vision become too poor. The sensitivity is not good enough, so they are unable to see the task properly. So they're just unable to learn.
Mm-hmm.
So that's what we recently using the electrophysiology evidence to show. Oh, because this guy unable to see well during the low brightness condition. So you need to use a very bright light and then almost like a sun, and then they can learn something else. Otherwise, they just, oh, I can't see it, so I'm not going to learn.
So you said it yourself, like it's quite iconic animals, and I assume, maybe I'm wrong, you will tell me, that a lot of students are actually reaching to you in order to work with octopus. And I think it can be interesting to actually know what you would expect from a student application to work in your lab. Is there anything that is important for you when it comes to a student application?
Yeah, because I'm not PI yet, so also the funding issue, so I'm unable to support many students.
Mm-hmm.
Yeah, so Yeah. So a lot of students approach to me and they want to do some project about octopus or something else. Especially a lot of people want to working on octopus behavior.
Yeah.
But if you only have 3 months for the semester project or master degree, just 1 year, it's really difficult to working on octopus. So I will
Yeah.
try to convince them if you want to do that, we probably need to start from some more fundamental or basic study. It's not direct jumping into the behavior project
Yeah.
because that almost unable to guarantee you can get the proper result. Yeah. Yeah. I need to spend a lot of time to explain the challenge for them to them and then make them to aware. It's not really easy to working on that.
Okay, but just also to be clear with maybe students who are listening us, like it is not mandatory, for instance, to be good at diving or this type of things, like because you have some projects that do not require to go in the water, I imagine.
Yes.
Yeah. Okay. Just
if you really want to focus on brand scanning,
yeah,
like a brand mapping, yes, you can spend a lot of time just in front of computer to
yeah,
try different algorithm to figure out the connections to construct the connectome, for instance. And then, or you can spend a lot of time in the microscopy to do the light sheet or some certain neural tracing. They will also spend a lot of time in the dark room.
yeah.
But I think our group, the advantage, we spend a lot of time in the field, but you also have a lot of training in the lab. So it's a good balance between the field and the lab. That make our group is very special. Yeah.
And so, like, I mean, if we had to go for a more personal question here, like, which part of your job actually give you the most satisfaction or joy, so to say? Is it the field or is it all the brain part?
Both. I like both. Yeah, because yeah, octopus just too special. Even just watching them do in the normal task like the hunting, then a lot new thing I observe during my snorkeling or diving, but there's very few information about how they can do that or why they can do that. So one question really bothered me for a long, long time is they are colorblind, but they can do camouflage. Even we, human, with the good color vision, and when they camouflage, very often you're just unable to detect them, even just 1 meter away from you. So that really is really fascinating. Yeah, even just watching them, I already feel so happy. Yeah, especially you spend 2 hours unable to find any, and then suddenly one octopus appear in front of you. Yeah, that's made me happy. And this brain scanning, that's also yeah, it's good. It's a very big challenge, but because we starting get progress, so we can see more and more detail inside the brain and try to link all those structure into their highly advanced cognitive capability and all their diversity. So that's really exciting discovery. Yeah.
Okay, that's very nice to hear. And so, like, long term, in a long term perspective, so like when you will be maybe more involved into teaching or this type of things, like, I mean, it's a discussion that we had with many PI that sometimes they have this frustration to not be able to be at the bench as much as before. Are you afraid, or are you already planning that even if you have to be more involved in other things, you will continue to just like go on the field and stay at the bench? What's your thought on this?
I would like to involve more teaching,
Yeah.
especially now I have so many. I already developed so many different techniques to study this fascinating animal. So I really want to teach more students to can use those new techniques. So that probably will help us to make this progress much faster. So I think teaching, that's the essential to make my knowledge can transfer to the next generation and they help more people. If they really interested in octopus or cephalopod in general, now we have some proper tool can do the more advanced research on them.
Okay. And that's like, if I can also come back a bit in the discussion more about your career itself, would you say that from the moment that you did your bachelor in Taiwan to the moment that you went to PhD and your position now, everything was smooth, or did you met difficulties? And if difficulties, like which one? And if maybe you would have any advice for early career researchers who are meeting the same difficulties on how to deal with them?
The challenge, a lot of them, of course, and many different ways. I think before I jump into cephalopod and really get into that, I already tried many different small projects. So learning what you don't like is much easier, but what you like, that's really difficult after you try so many things. Yeah. So yes, I got some idea, or when I spend a lot of time in the lab doing a lot of pipetting, doing them. I like that technology, but I'm unable to spend my whole life in the lab just doing that. So I need to go out to learn something, and I know, oh, I can use this technique to answer some questions. So I think for the young generation should spend time to explore different directions to figure out what is really suitable for you and what you really like it. And then you can spend more time, or much easier to stay in that field rather than just, you frustrated because one challenge you're unable to overcome, then you give up. Yeah. I encountered this kind of challenge many, many times from the very beginning to now. Yeah, but because I like this animal so much, so it always bring me back, and figure out the different way to tackle my question or overcome those challenges.
Okay. And so like still on the page of the challenges, so like you are in Australia, so in Oceania, which is quite far from over continent, and like and over continent that may work also on your field. I was wondering like how is this a challenge, and like if it's kind of easy or hard to build up international collaboration or even just network internationally?
For my case, probably a bit special because very few people working on cephalopod brain.
Yeah.
So I really get the opportunity to meet almost everyone in this field. So
Okay.
I know many of them. And then because my approach, we can see a lot of detail I'm able to see before. So now I really get a lot of collaboration from many, many countries. Yeah.
Yeah, okay. So like you are not limited by this.
Mm.
But would you say that maybe in the more like, I mean, because I understand that you are a very specific case because like you are working with models that are very specific, but like you living in this institute, like do you have the thing that for other researcher it can be complex sometimes to build up an international network?
Yes, because we are quite far away. So we establish those cooperation, need to attend a lot of conferences and then meet people and to know people, and also proper conversation, then you'll get better idea what we can do together and what I can support you, or so like because our diversity is so high, so that's really our advantage. We can do a lot of comparison study. But for instance, in US, they focus on certain a few species, but they really go very deep. So from the molecular level to the anatomy level, everything. But now we more like an evolution approach, so we can do the comparison to have the big picture, what is going on in such high diverse situation. Yeah.
And is it something that, so I'm coming back to science here, like, is it something that you are actually planning at some point to maybe just make some meta-analysis of data coming from different lab in order to see, to reply to this question of evolution?
Yeah, potentially, but we still working on that.
Yeah.
So I have cooperation in UK. They
Yeah.
are working on synaptic connectome.
Okay.
So that's very fine detail. And then another American team also working on different species, but also approach to the different angle. So we will have the meso resolution and then to the synaptic, to the micro resolution. So for, yeah, give us some time, they will eventually can combine all those different scale together and then have the mega analysis. Yeah.
Okay. That's nice to hear. So like, I mean, to kind of follow up on these two things, like, because one tool that can allow to actually bypass this problem of international networking, but also to outreach people are social media, and we saw that you are using a lot social media to kind of like highlight your research, and we were wondering if you think that social media and this type of new media as being a very important part of outreach nowadays and also of networking.
The new media, I'm not really get into it because it changes so fast. So it's
Yeah.
really difficult to follow up. But I do have a old style Facebook page. It's called Cephalopod
Yeah.
at Taiwan.
Okay.
But I have that one for more than 10 years. So I regularly publish the information about the image and about some new study. And that really helped me to have the very good link with folk in Taiwan. So I always have those updates directly from either my colleagues or the follower from Taiwan. Yeah. Recently, because the so many different platforms, I don't really spend a lot of time on that anymore. Yeah.
Okay.
Do you spend time doing outreach? Do you go out to schools and so on? Do you
Yes. Yeah. School, like a primary school and high school. Yes, we do the outreach, and then also university have the open day. So that's
Right.
very easy to approach many different peoples, from the kids to the elderly. Yeah.
And is that
And
supported by the university, or is it does the because sometimes we hear that it's almost seen as an extra that people choose to do rather than a core part of their job.
I guess because we work in the marine station very often, so we have very good connection with the local community as well as the station. So we actually happy to do that. Although it's like an extra job, but it actually expanding your research to make many people know what is going on. Yeah. And as occasionally, yes, we can get some donation from the alumni or from the people who want to help us to do more research. So that's also, yeah.
So how it works in Australia, like because I know that in Europe and North America we have more and more of this outreach company, so to say, like that. We really have people specialized in this that are doing the outreach for researcher. Is it something that exists in Australia? Is it something that you think it's a good idea in that sense that somehow it remove this time of outreaching from your schedule and you can focus more on research?
Yes, there are a few similar company doing this kind of work. I think our group is really lucky because we're working on very special cases like fish, deep sea, and cephalopods. So we actually help a lot of documentary productions. So
Okay.
like a BBC, we do have several programs with them, and the NHK Discovery channels. So very often we've been approached by these different teams, and then we can make the documentary that's really have the big impact globally. Yes.
But then actually, like how, because I think it's something that we are not really prepared for. What will be your advice for early career researcher to prepare this type of intervention in a documentary, or like when media are coming to talk about their own science? Like, how do you prepare this ahead to be sure that you are not saying something that will be keep against yourself, because it can definitely happen.
Yeah, it might happen. Yes.
Yeah,
I guess practice.
yeah.
Yes. Yeah.
But is it something like you practice yourself, or like, or do you participate sometime to workshop in order to know how to prepare this type of things?
Uh, uh, my case is probably too special because I really get involved so many different documentary productions. So
Hmm.
I get involved in the from the beginning, the research stage, and then how to put the story together, even the filming and explain all those detail. Yeah, so I also learned a lot from the documentary production team, how they put the story together. That's also helped me to how to construct your paper. It's
Ah,
like a
okay.
storytelling. It's
Yeah.
not just present your data. It's make your study more attractive to engage with people. Yeah.
And is it something that already crossed your mind? Like, let's say at some point in your career, say, okay, I'm done with research. I will start producing my own documentary on octopuses, and just like
No,
enjoy. No, never.
no.
Okay.
Yeah, that have a lot of team can do that. I will focus on my study. Yeah.
But it never crossed your mind anyway to actually stop research. Like you've always been in this idea that you will just keep going.
But yeah, if funding is not a big issue, I will keep going. Yes,
Yeah,
I
yeah.
really
No,
enjoy. Yeah.
sorry, I'm not talking about funding here. I just like you never had this thing that, oh, okay, like it's not for me. Yeah, very, very interesting. So like, I think we will run out of time. So I like we like to finish with this rapid fire question
Okay.
series. So
Yeah.
yeah, like the idea that you need to kind of reply as fast and as short as possible. But no
Okay.
worries, none of the question can actually be used against you later. So okay, the first one is that if you had to explain your research to a 10 years old in one sentence, what would it be? I guess you already trained a lot for this one with your kids, so
Yeah. So how octopus can squeeze through the little hole because they have soft body.
okay.
Yeah.
Looking back, what would you tell to your PhD or postdoc self?
Myself.
Yeah, but looking back, like,
Well, it's a lot of hard work, and then yeah, to be to be tough and kind to yourself and your team.
that's a great advice. So I think I'm not wrong. I read in an interview that your parents wanted you to be doctor, right? I mean, to be a
Yes,
medical doctor.
medical
But
doctor.
yeah, if you weren't a researcher, actually, what you will be doing now? Would you be doctor like your parents wanted, or something else?
Maybe yes. If I didn't go become a biologist, very likely I would redo my exam and become medical doctor.
Oh, okay. What is your favorite animal? Even if I imagine that we already have the answer. Maybe what is your favorite species of octopus will make more sense here.
All right. At this moment, it's the blue line octopus, the venomous one.
Okay.
Yeah.
More coffee or tea while working?
Pardon? I don't understand.
Coffee or tea when you are working?
Oh,
Do
okay. Yeah. Definitely need coffee in the morning, but if I need to dissect, no coffee.
Okay. One moment of your career that remain unforgettable.
When I saw the first ever live giant squid.
Sorry, life what?
Live giant squid.
Okay.
Yeah.
That's so like it's something that will remain really for you.
Yes.
Yeah. When was it?
Yeah. So let's back to 2012.
Okay.
I was in the documentary production expedition, and then we use our deep sea camera to deploy down to 700 meters, and then we
Okay.
got first ever shot video footage of giant squid attack camera.
That's really nice. So I guess that people can see it on this documentary, this shot.
Yes.
Okay.
Yeah.
If it was possible, is there anything that you would like to change in your career path?
The path, I probably would stay the similar path, but I probably will spend more time to learn some to improve my mathematics skill.
Okay. Yeah. I see.
Yeah, especially now, so many image processing get involves the very complicated equation.
Yeah.
Yeah, sometimes I'm really struggling about that.
Okay, so like main message, people just learn your math at school.
Yeah.
And what is the most surprising thing that you have learned of octopus?
They are so weird. It's just unexpected. Yeah,
Okay,
many new discovery. Yeah, it's just very often just yeah, they are so
so
weird.
so pretty much everything is surprising. Okay.
Yeah.
To finish, like, do you have any recommendation for book, papers, any resources that people could discover a bit more about your line of research or maybe about other line of research?
I think if you really like cephalopod and then want to know more, I think the cephalopod behavior is the very good book everyone need to read.
Okay.
Yeah, so you know the general behavior and the ecology, their lifespan, and the life history. So I think that's the first book you should get in.
Okay, that's a good recommendation. So we are actually arriving at the end of this podcast, like time is flying. So thanks a lot, Wen-Sung, for being with us today. That was really nice to hear about your career journey, and also to hear more about octopuses, because let's be honest, it was hard not to talk about them. And so yeah, like I mean, I think that the main message is definitely that if you are interested about marine biology, do not forget that you need to love ocean and sea by itself and not just the species. It is quite important, and thanks, Wen-Sung, for reminding us this.
Meet the PI is presented by Animal Behaviour Live, an inclusive international platform bringing together animal behavior researchers across the world to discuss the latest research and question our academic practices. To know more, check our website at animalbehavior.live.